Kubernetes is just Linux, right or wrong? In today's episode of Cube FM, we'll be speaking to Eric Jalal, who will explain how Kubernetes might seem complex at first, but is fundamentally built on familiar Linux features. In other words, for Eric, Kubernetes isn't an entirely new innovation. It's more of an orchestration layer that wraps existing technologies to manage containerized applications at scale. It shares concepts with other orchestrators like Docker Swarm and Apache Mesos, but stands out due to its simplicity and flexibility. Kubernetes is built on top of Linux and relies on Linux APIs for its functionality. So for Eric, it's essential to understand Linux in order to work effectively with Kubernetes. Eric shares with us his experience about learning the fundamentals of Linux, such as file systems, networking, and storage, as they are crucial for working with Kubernetes. You'll learn from him about how Kubernetes provides a standard and consistent interface for managing Linux-based infrastructure, and also get some great book recommendations. Join us as we discuss how Kubernetes takes the best of Linux and packages it into a powerful, efficient orchestrator. This episode is sponsored by Learn Kubernetes. Learn Kubernetes, or Learn K8s, is a training organization that helps engineers all over the world level up their Kubernetes skills, from beginners to advanced. There are courses that are online and also in person, which are 60% hands-on and 40% theory-based. And students that take the courses have access to the materials for the rest of their lives. For more information, go to learnk8s.io. Now, let's get in the episode and talk to Eric. All right, Eric, so can you tell me about which 3 emerging tools are you keeping an eye on?
Yeah, thanks for asking about that. Well, if I want to be honest with you, there is no specific tools that I'm really following about. There is many tools that I'm following all the time. One of the most important of them is the container application. This is the biggest challenge that I have always in different organizations. When you're setting up the Kubernetes cluster, you usually have lots of challenges with the Linux servers, like at the bare metal level. And if you're using some public cloud providers, you don't have those issues. Well, you have some other issues. But then since recently I'm working a lot with the Hetzner providers, and I'm setting up everything myself, I'm choosing different container run times for Kubernetes, and I'm following so many of the projects there. I don't know if you know this Lima project as well, and Colima, for example. Well, Colima is based on the Lima, and those containers, and they are like the projects that I'm mostly following. But also, yeah, well, Kubernetes project itself, I follow that all the time, and I go to the meetups, and yeah, that's the biggest thing that I follow, to be honest. Yeah, but there's many because I also sometimes build myself some operators, and I put it in the company organization GitHub, and I follow those as well. So yeah,
Very good.
that's my
And
situation.
for people who don't know you, what do you do and who do you work for?
Yeah, well, I'm an independent consultant at the moment, and I do Kubernetes development. Basically, I started as a DevOps, and I joined companies as a DevOps engineer. And I say DevOps because DevOps is more of an infrastructure person, but nowadays you can see these other names like SRE, infrastructure guy, or DevOps, or they're like different, which I totally believe that they should exist. But there is projects that I have to develop a new tool. For example, for GitHub, there is a project that I have to develop a complete new cluster, or or investigate on its security side, which is basically most of the time in Kubernetes side. So yeah, that is what I do nowadays mostly.
Very good. And what was the process like for you, getting into cloud native? What were you doing before, and what was it like becoming more of a cloud native person?
Yeah. Well, I started as a backend developer. So back in the day, there was this Java language. I'm talking about like 15 years ago. It was quite booming at that time, and so many people loved it, and it was kind of competing with .NET framework of Microsoft. And at that time, internet was not, at least in my country, wasn't really that broadcasted. Like not everybody in their houses had internet. So people were using a lot of Windows applications, and then I wanted to build softwares, but at that time it wasn't like web applications. It was mostly Windows applications. And since everything for Windows had to be paid for, I didn't have a Windows for a very long time, and I was using Linux, and Java was the best option for me to start learning it. And then I was using that with NetBeans, and everything started from there. And then it took like 7-8 years, and then after that, because I was all the time doing backend development, API development, working with the databases, scaling them. Then I went a little bit more deeper, and I asked my managers that, hey, is it okay if I go pick like tickets that are more related to the virtual machines and basically our infrastructure and things like that? And they were quite supportive, so I could get there as well. And this Kubernetes was a really interesting topic always for me, and it's very close connection with containers, which are again very interesting topic for me, and they are all are childs of the operating system, which is in this case Linux, and that was again very interesting for me. So it went like quite 3 or 4 layer stove to here.
And the Kubernetes and cloud native ecosystems move very quickly. What works best for you to stay on top of things? I know you mentioned you go to meetups, but also what are other resources that are good for you? If they're books, if they're blogs, if they're videos, if they're podcasts?
Yeah, you just asked that how I keep myself updated. Well, just by reading. I read a lot of in GitHub there is this watch button for those projects that I really love, and sometimes I do contribute. For example, there is some Facebook repositories that I contribute actively, and also this Runc, which I also work on that as well, and Terraform, some providers I have been writing later on with Golang. So these are the things that I work on, and they are like the most important for me. So I keep myself updated usually by looking at my GitHub notifications every morning. Those are things that I closely watch. I'm kind of a watchdog on them. But the other ones, like the more other projects, Twitter, for example, so many people, you can just follow them as they are like DevOps people or basically technology guys. They so many times put themselves, their experiences there as well. And now recently, I have Medium subscription, and from there I get a lot of good topics here and there, and they just give me a very brief information about these new technologies and also connections to other technologies, because they usually explain that, okay, I connected this and this, and this is where I ended up. And I really like that to read them like in the bus or something, or when I don't have anything to do.
And if you could go back in time,
lifestyle kind of thing, not really academic advice that I have for
no,
people.
that makes sense. That makes sense. Yeah, that makes sense. And if you could go back in time and share one career tip with your younger self, what would it be?
Well, with my younger self, learn Git and C++ much better. Well, C++ was C, I can say. C and C++ was quite, like, I understood it completely differently than what I would expect now from myself back in the day. How I would cope with all of those concepts, and especially the data structures and how to build them and things like that. If I had this understanding that I have now at that time, that what level of understanding you should have from these concepts back in the day, I would probably be now in a better position, because it took me many years to understand what am I missing, and understand this fact that I am lacking some fundamental understanding in the technologies. So I have to go back and learn so many things that I missed because at university, at some point, I was quite naughty at that point, and I was younger, and I was just trying to pass the exam. But now, if I go back then, I wouldn't just try to pass the exam. I would understand and try to learn much more and too many other things. And there is this Git. When I started university, Git was probably 6 years or something like maybe 5 years, and it was getting a lot of reputation, and there was a lot of advancement on Git side from then till now, but in the beginning days, if I understood how exactly Git works and also contribute to that project, that would be also a very huge achievement. Because Git is a so big project, it is amazingly engineered, and it is amazingly complicated, I would say. I mean, it's one of the most complicated architecture I have ever seen, and it is so interesting. So yeah, and it is the backbone of every company, every technology company who is using code. I mean, Git is basically it's basically the glue that is putting everything together.
As part of our monthly content discovery, we found an article that you wrote titled Kubernetes is Just Linux. So the following questions will be taking a closer look at this topic. It's interesting, that this year Kubernetes celebrated its 10th birthday, whereas Linux celebrated its 33rd. But to start out, how can Kubernetes and Linux be just the same?
Yeah, Kubernetes is the father, basically. The Linux is the parent of this Kubernetes. And it's not only Kubernetes, it's also the containers. There is a super close relationship between all of these. So I'm not saying that they are the same exactly as they are like doing the same thing. Linux is an operating system. Kubernetes is orchestrating the operating systems, but the smaller operating systems. So all of the functions, basically, they are based on the Linux operating system, and Linux is empowering Kubernetes to do the actual job. 50% of the infrastructure work all the time is plumbing. What is plumbing concept here? It is basically when you have already so many components invented and they are working standalone, but then when you connect them together and you make new automation, you basically renovated a new piece of technology. In this case, it's Kubernetes. So what do you have in Kubernetes to plumb them together? You have etcd, you have control groups, you have volume system in Linux, you have the networking interfaces. All of these has been already there in Linux, invented from a long time ago, and now Kubernetes is just connecting the dots and also adding lots of logics on top of it. So that's why I call Kubernetes a renovated for a specific domain of the operating system that is called Kubernetes project. So it's not inventing anything new, it is connecting things together.
And it's not a secret that Kubernetes is a complex piece of technology. However, in the article, you argue that Kubernetes is simple. And we've been doing this podcast for over a year now, and I've heard very few people saying that Kubernetes is simple. What's your argument for that?
Yeah, well, I don't know why people say that it's difficult. So that's my question too. Well, I'm not saying that it's super, super easy, so then just out of the box you can start using it. Of course, that's not really possible. You should know what you're doing. What I'm saying by easy is that it is not rocket science, because when you know already how does it work and how does things work together, it is much easier to connect yourself with this technology. So just imagine that if I tell you that this Kubernetes is doing completely everything, like if I ask you that how networking works in Kubernetes, in your brain, if you do not know that, this is another piece of technology that still is using IPs, subnets, and this is the connection basically on that protocol. So then how would you answer this question? And you wouldn't think that it is like debuggable, or you can just diagnose things based on the current knowledge that you have already. And what are the places that you can easily, for example, SSH into to read logs and debug something, diagnose something, So this is another example about this fact that the fundamentals always rock, and they are much more important to learn than just going ahead and learning only the new technologies. And when you know already how this is smaller piece of technology, so for example, this networking and for example, a storage system, how they are working and what are they exactly, even the data structures and things like that. Linux command line, for example, that's a very important thing as well. Those are your right tools to learn and work with Kubernetes, and it makes your life much easier. And also it makes you capable, easier, dive into the documents and find your way into this Kubernetes, because even in the Kubernetes documentation, what you're finding, those are all terms and names from the technologies inside of Linux. Like, let me give you an example. For example, the downward API. It is providing you the metadata from your container to the kubelet, and then the control plane process them, and also then you tail the log out of it, and then you understand what is happening inside of your cluster, inside of your worker node, for example. That's just an example. So this circulation of data, how is it happening is just based on the Linux commands that they are there already, and you wouldn't know that it is possible that you read the data when you are launching something in your container. If you don't know that, okay, this is Linux, this is working like this, and then I could do that. Then also sometimes you can also contribute to the code as well. So this is like, for me, it doesn't tell me that this is really a difficult thing to do. I would say that this is a wide technology that you should know from many things at the same time. I should have different experiences so you can actually struggle with it and fix your challenges and things like that. So what I call, for example, difficult is how, for example, these C groups in Linux is really implemented. This is really really much different, very much deeper side of technology that is compared to, for example, these couple of APIs that we are just telling them how to do it. I mean, I limit you and you are acting inside of the limitation, but how that limitation is applied on you as a process, that is the difficult part, which contains a lot more technology, and not technology, but I mean science inside of it to understand and implement it, how it should happen on the CPU side, because you're going more on the hardware in that area.
So then, is it safe to say that Kubernetes is just a wrapper on top of Linux?
I cannot say like the whole Kubernetes idea is a wrapper on top of Linux, but as I said earlier, 50% usually in these technologies is just plumbing, right? So there's a lot of other components invented around it, and they are connecting the dots together. But yeah, a lot of part of it is wrapping the Linux APIs. Let's think about it like this: that you have this Kubernetes. Kubernetes already had so many similarities to the code that we have in Docker. Docker is a bunch of plugins that has also the orchestrator that can control the network interface, the storage interface, all of these. But this is not the container part. The container runtime is called Docker D. And then Docker D also is talking with another low-level container runtime, which is called runC, right? There is also other alternatives than runC, but the thing is that each of these layers, which there are too many, they are designed to talk with different part of the system and actually wrapping other components of Linux, which at the end of this line is connected to kernel and kernel to the hardware. So they all come up, and there's multi layers of different technologies, from these lower levels runtimes to the higher level, and to the basically to this controller, which you call them, for example, Docker Desktop. It's another on top of basically the CLI Docker, which is the Docker GUI, right? So that's why these are all all based on the operating system, and they all connect to each other, the same APIs. And why did we have many? But because we have just one Linux, we have multiple distros and one kernel. But why we have many container runtimes? Because each of them are designed for different purposes, and they have different scope of engineering. For example, Container D is more lightweight than Docker D. You know, there is also other ones, and yeah, there is. I don't know how much I can get into details, but in general, I think I answered the question.
Let's focus on pods and containers for a second. If Kubernetes is wrapping Linux APIs, why was there a huge fuss when Docker was replaced as a default container runtime?
Yeah, well, I don't know when actually that happened. Well, it's a good example. I don't really need to know when Docker was replaced as the default container in the runtime, because I was never forced to use it. This is one of the beauties of a modular system like Kubernetes, because you can easily replace different components with what it is fitting your need. There was I don't know exactly why people were a little bit surprised that Docker was replaced as the default container, probably because Docker is having a lot of overhead, and it has like a lot of plugins that most of the time is unnecessary. So that's why, at least in any of the Kubernetes clusters that I worked on, we never used Docker as the default container runtime. It was always CRIO, or, for example, Container D, and things like that. And there is like many alternatives there. But to get back to your question, well, Docker and any other container runtime are using the same approach of shipping and packing the software, and there are definitely differences between how each of them are optimized in what way, but still, it doesn't change the fact that the underlying system for all of them is Linux, and the main enablers are those segregation functions that kernel has defined much earlier, like the network interfaces and memories and disks and managers like that. So they're all doing the same thing, but For example, the main difference is between, for example, some technology like Lima or Docker is that the Docker is using the HyperGit to create the Linux environment to run the container. Then Lima is using the Linux VM, for example, on the Mac OS, right? At the end of the day, it's all the same thing that is going to be achieved, but what is the most optimized way for our need? That's what we strive for to achieve.
So it kind of looks like it's turtles all the way down. I mean, how many more layers can we have?
Yeah, too many. Also, not only downward, but also upward. Like you can have many other layer on top of it, which can create you these other technologies, like for example GCP or AWS. Nowadays, I mean, I don't know why it went like this in the technology. Well, probably because it has become quite commercialized. That they wanted to make a lot of money from these open source and free technologies that they built. For example, this AWS, and then it was like, now we have to take a lot of courses and certificates to understand that AWS, how it is working, even though under the hood it is still using the same technologies, containerization, virtualization, and orchestration, which they are all invented and also getting upkept by the open source community. And they came actually to help our life, make it much easier. But on the other hand, they are not doing that, and they are adding a lot of overhead, too many things that we don't need to, and we are paying for. But the other thing is that there is a lot of limitations that they are adding for us, especially when it comes to the security part. There is so many things they have that we don't need, and there is so many things they do not have, and so many limitations they add to the organization. I can talk a long time about that, especially since I've been setting up some AWS IAM systems and security groups, and so many logical problems they have that I do not understand why it should be invented like that. But I go a lot of marginal talks from your questions all the time. But yeah, the layers do not stop really. It goes down from Kubernetes to your containerd, to your run C, then to your hardware, then to your manager. But the thing is that the problem is that when and if you have is understanding that what you're doing and what this term and how things are invented, then you have a much easier way to find your way in. And this demystification that, okay, what has brought me here, and how this piece of technology is invented here, then it helps me at least to understand a lot of things when I want to debug my problem and also design my solutions. That this designing of the solution is also very important thing for. I can also bring an example for you on the business side. If you do not know exactly what you are when you are working, because there is so many different points when you are, for example, opening a new VPC, you're like creating a new VPC. If you do not exactly know, for example, what is a NAT, what is a public gateway, you can easily route mistakenly company internal traffic through an external IP, and then from your NAT gateway, you get a lot of costs, even though it could be free if it was routed from the VPC peering, for example, right? Because it was internal cluster and it was going to be free, right? And then these subtle problems sometimes get cached easily, sometimes cannot be caught easily. So they produce a lot of loss for your company. So this is also having a business side as well. So that's why it simply not knowing that what is the difference of NAT and simple peering, how much it can be problematic for you.
Now, back to the Kubernetes pods and limits and requests. What Linux API do they wrap?
There is many on the limit side. There is, for example, control groups. There is SE Linux. Basically, SE Linux is a standard, but seccomp, I can say, this is the function parts of it. And in Kubernetes, the allocation to the CPU processes is happening by an API called this CFS, for example. And just bringing it as an example. This has a mechanism to report the CPU bandwidth, and in a system, it is dividing the allocated processing power, computing power to each of these requests coming to each of those pods, where basically after the request router system. It is dividing it based on the percentage, and also based on the request, because sometimes, for example, the pods can throttle, and then they accumulate more CPU percentage, more CPU usage than what they have, what they are limited to, or what you. And try to enforce that limitation by your YAML. But this is the part, for example, that I told you in Kubernetes, that there is a lot of other technologies, and it's not only wrapping Linux API. So it sometimes decides to give some space for drifting to your pods, for example, right? Because it doesn't want your request to be failed, and your pod doesn't need all the time for some throttling to be restarted or crashed. For example, this is one example. So yeah, this is one other example about this limits and request limits that you asked for, but there is still a lot of other things. And it's not only limitations to the request, it's also expansion of the requests, like, for example, the networking part. There is, for example, eBPF or IP tables and things like that, which they are coming from Linux, actually.
I imagine that there must be several knobs that you could turn to adjust settings on how the CPU is allocated to those processes. How are those then wrapped and exposed in Kubernetes?
Well, they are wrapped and exposed with YAML. Which they come to the control plane when they are pushed there, applied, basically, those manifests, and the master node discuss this matter with the kubelets, and it tells them, okay, you have to control the processing power, the computing time by this manifest that I'm giving here to you. So this is how the workload basically gets spreaded by the scheduler, and there is also many other many options here and there, and also there is too many details there, because this scheduler doesn't work this easily. There is tainting, there is labeling of the nodes, and those are also effective parameters. And also the disruptions, like the disaster recovery, or also the controls that you want to apply to your nodes and basically the cluster, because there should be Kubernetes is designed, and it's actually one of the beauties of Kubernetes, is that it's designed with the this idea in the center that users should experience the basically the uptime, the maximum uptime. And that's why, for example, if your master node drops and it is getting restarted, for example, none of your worker nodes will be touched. Nothing happens to them, right? So that's why it is designed like that. I cannot just forecast when I apply this limitation or anything like that to my Kubernetes cluster. It is going to 100% of the time act as I'm expecting to, because there is also many other mechanisms designed for your pod to change itself and be flexible enough to keep the system up and running as much as it can.
So is it fair to say that Kubernetes wraps the Linux API but has some opinions about it?
Well, I don't know really how to answer it, but wrapping and exposing an API, it's not a very easy thing to do, right? Also, it should be lots of different compatibility, and too many different case scenarios need to be seen, and lots of tests need to be done, and so many experiences. This is something that was already happening in huge data centers, in Google data centers, and so many of those people are actually still main contributors of this Kubernetes, which we are now talking about that. So there is also a lot of best practices behind this Kubernetes idea, and this has made kind of a model how you have to deploy a software and how it has to be deployed. I mean, who gave initially this idea, this paradigm that if your master node drops, your worker node still needs to stay up? It is basically a best practice. It is something that is designed for purpose. So Kubernetes is also serving a purpose of highest uptime, flexibility, and also modularity, right? So this is not only, we are not only talking about APIs, we are also talking about business, talking about mapping and organization consisted of thousands of developers for maintaining and building hundreds or dozens of products, and we all need to work together, and also we should have flexibility and agility for CI and CD processes. And this is designed around that. So that's why I do tell that Kubernetes is just wrapping Linux, but not only Linux. It is a combination of software developers coming to dev and ops, develop and operations together, designed this for those purposes.
So does the value of Kubernetes mostly come from an opinionated API?
I don't know how exactly to answer it, but it's consolidating a very standard and consistent interface. You know, because it abstracts a single Linux host and offers an option to connect several Linux servers together, and it wraps APIs and makes a higher level abstraction. So the operators doesn't need to know how many steps are necessary to create, for example, C groups and assign it to a process, right? So, yeah, I would say that no.
Okay. So we've talked a lot about Linux and Kubernetes and their relationship. What I got from our conversation is that if you are new to Kubernetes, you would be better off learning to use Linux instead of Kubernetes. And the corollary to that is that if you've already mastered Linux, learning Kubernetes is an incremental step. You need to map your mental model of how Linux works into Kubernetes. Am I correct?
To some extent, yes. Well, basically, the idea here is that you should learn how to learn. And to me, if you want to learn the infrastructure very well, and since the infrastructure is basically always running on top of either Linux or Windows, and it's not always Linux, but that's for sure. There is also Windows here as well. You should know your operating system very well. I mean, the more you know your operating system, the easier you are going to work with the infrastructure softwares on top of it. Because at the end of the day, all of those infrastructure softwares like this container runtimes, like the orchestrators, they are going to control, they are the handles of controlling those operating systems and also the databases. And this is the entities that we have here. So in this case, especially about the Kubernetes, because Kubernetes master node only runs on Linux. You cannot run it on a Windows. So you definitely always need to know Linux. And probably you might say that to what extent I need to know Linux. You should know how Linux works. What are the file systems? What are the networking? And what are the different types of the, basically the SDS, software-defined storage. That is one very important thing, for example, because then how you would know the difference between a volume claim and a persistent volume claim, a PVC. And what if I ask you that I have a huge object like 2,000 of gigabytes of objects to a storage? How can you all of a sudden understand you need an object storage, for example, called Ceph? How you're going to configure it for me, and how can you configure it to my already running on production system without building a whole new cluster and just updating the current cluster without my user getting notified and have a seamless migration to this new feature that you are going to add. So these are all coming from the fundamental understanding from your operating system, in this case, especially Linux.
In terms of your fundamental understanding of Linux, is there any book, course, or tutorial that you recommend for someone who's starting with Linux?
Yeah.
What was your learning journey like there?
Yeah. Prior to this, I have brought this book that I really loved reading it. I don't know if you can see it already here. So this is the Unix and Linux System Administration Handbook. It's a quite long book. It's about 1,000 pages. You really don't need to read all of it, especially the email part. But the thing is that it gives you a great knowledge and for administering your Linux. And also I have another book called Linux Bible. They have lots of same knowledge here as well, but the Linux Bible gives you a more high-level picture about how Linux is basically designed, and that's also very beneficiary, at least for me, to understand what is the domain that my operating system has even thought about to handle. Because it comes also not only from this CPU and storage and things like that, it also tells you that how Linux get connected to a printer, right? So this is because these systems are enterprise level designed, so you can understand that how organized and capable they are. So then you know that what are they capable to do. But then when you read an administration handbook, then it gives you a lot of knowledge and also names to the softwares that they come by default on kernel. And they are in all the distributions, not all the distributions, probably in Alpine you cannot find too many softwares there. But in general, what are the tools that you have? What are your fingers under under your fingers when you're SSHing into a machine and trying to diagnose something. Or for example, what is promiscuous mode, for example, in your Linux machine when you're debugging it somewhere, or what is a WireGuard or things like that.
Do you think there will be a Kubernetes without Linux in the future?
No, I don't think that it will ever happen. It is already quite advanced community of people working on Linux, and Kubernetes, I initially wanted to say. So I don't see really any reason to rebuild or reinvent the wheel. I think we still have a lot of things to do on Kubernetes, and yeah, there is too many things left for us.
So when you're not working on Kubernetes or Linux, we found out that you're a huge fan of bouldering and also a professional Call of Duty player. Can you tell me about that?
Yeah, it's sometimes that I'm not playing computer games because I'm kind of busy with life, but usually I at least try to find time like 1 hour a week to play. Yeah, I'm quite professional in playing Call of Duty. But yeah, I also try to go to the gym to try to stay healthy, and because all the time sitting behind my desk is also not a very healthy business to do. So yeah, this is the two things I do, and I really love bouldering because it's so exciting. Yeah, I would say. I started from like 2 years ago, and I really recommend it to all the developers out there. Yeah.
What's next for you?
What's next for me? I have so many ideas about the tools that I'm creating. I have built many different tools for SRE teams in different companies, and I haven't had time to make them more complete, and sometimes add more features, and then make an open source version of them and put them on my GitHub. This is one of the things that I really want to spend time on it. And also blogging, also I have a lot of scenarios that happened for me that I really wanted to transfer them to the community and kind of give back, to tell that, okay, this is really something that I experienced, and I paid a lot to get out of that issues, and I taught a lot about it, and I got consulted a lot. So they really worth to give back to the community, but I didn't have time to do that. So those are like the two main goals that I have for my career to do a bit, working on more on the open source projects and also blogging. I really like to do. But yeah, other than that, continue what I'm doing and gaining more knowledge and enjoying life as well.
What's the best way for people to get in touch with you?
Yeah, well, I have Twitter, Jalal Eric, with no space or dot or anything like that. That's my handle on Twitter, which is nowadays called X. And also my email is eric.jalal@signlinux.com. It is also my email that they can send me an email, be in touch with me. I would be glad to help. Definitely. Yes.
Fantastic. Great. Well, Eric, thank you very much for your time today and for sharing your knowledge. Looking forward to your next steps, whether it's Linux, Kubernetes, bouldering, or Call of Duty. Wish you nothing but the best. We'll be speaking soon. Thanks a lot.
Thank you.